Great. Did I pronounce your name right?
Yeah, you got it.
Okay, cool. So yeah, so today I just do a coding interview with you, and we start with the coding. And if we have spare time, then feel free to ask me any question you're interested. Team or function.
All right, sounds great.
Great. Okay. Do you have access to the chat? Do you see that?
Did you paste the question?
Yeah, just did.
Do I have the right link? Let me share the link that I have.
And so it's 92 pp.
Yeah, that's what I have open. It just shows me an empty file here, or not empty, but a main file.
Yeah. Is there some latency?
Okay.
That's it.
No worries.
So let me just talk about the question. So it's serialize and deserialize a binary search tree. So you have a binary tree node which takes a value and the left pointer and right pointer. So I'd like you to write two functions. One is serialize, which takes the root node of the tree and output a string to represent the binary tree. You could choose any encoding mechanism like space or comma, anything that makes the implementation easier. But we could consider efficiency later. And there's another piece. Have you seen that? Not yet.
I still don't see it. Could you maybe have to refresh? Let me also refresh mine. Let's see. I don't see anything here.
Oh, let me refresh it as well.
Okay, now I see it. A question I had: can I do this in Python, or does it have to be in C++?
You could do it in Python. I would prefer C++, but if you're not familiar with like modern C++, we could remove all those templates and unique pointer, just use the raw pointer if that makes it easier.
Okay. I admittedly never use C++ in interviews, but I'll try my best. I typically use it for like regular production code, but I'll try my best here. Let me see. So you said I should serialize the tree node?
Yep. So serialize the tree into a string, and then the serialize function just do the opposite. It takes the string from the previous function, construct tree, and then return the root.
Okay. That's a tricky one. All right, so let's see. Include our stream, struct tree node val, tree node left, tree node right, class codec equals this tree to a single string. Then have some serialized function, tree node roots. Okay. And are we going to run it in the end? Does it need to be fully compatible?
That's preferred.
Okay. So let me see. How do I want to address this? Okay, so the serialized part should be fairly straightforward. So let me start with that one. I want to do this. So given a string, serialize, I imagine I can use, since it's a tree, I imagine some search function is good. So something like BFS might be helpful here for a tree. So I'm going to write out some thoughts at the top. And I'll sort of walk through how I'm thinking to solve it. So BFS is probably good for a tree. Let me think. So the base case is if the string is empty. So if I'm at this root, I'm gonna. You said it's a binary tree, so it's gonna have a left and a right node.
Yeah, that's right.
Okay. So make a note of
and
that.
To make it just to not confuse you, it's literally a binary search tree, which means that left node is smaller than root and right node is greater than. There's no kind of no duplicate values.
Every node I don't have to worry about input being invalid. It'll always fit that constraint.
Yeah, that's right.
Okay. So binary search tree, probably gonna run BFS. In that case, I want to some queue and push left node and right node. Push. So push left node and right node into queue. And how should I represent it? Do I just put like commas between each node? Okay.
Yeah, it's up to you. Putting comma is definitely one way. I mean, you could even put brackets around the node. That's also fine. Literally, it's just like whatever makes the program easier.
Okay, that sounds good. Commas or brackets around each node. And I'll focus on serialize for now, and I'll come to deserialize after. Serialize. So serialize, I'm going to BFS, I'm going to have some queue, add some comma around each node when I'm at the end, the base condition. So yeah, that feels pretty straightforward. The deserialize will be a bit more tricky, so I'll probably jump into the code first to serialize, and then I'll come back to deserialize at the end. How does that sound?
Actually, before that, this is how you choose encode the string would affect deserialize function. So maybe
I see what you're saying.
Code the deserialize function. Just think about it. Like, say if you given a string like something, how would you deserialize it?
Yeah.
Then make sure.
Yeah, I'm going to use a comma as sort of the format for deserializing as well.
And also, the tree might not be complete, meaning like it might not have a right node. In that case, from the string, how would you tell like which string represents which node. Like if I give you 1, 2, 3,
Yeah.
how do you know like one is this is the easier case, but if I give you like 1 to 5, I just made it up. How do you know 5 is the right node of which root?
Okay, so you're saying so I could have some placeholder value that would represent that. So in that case, I'll have some at symbol. So I just say at equals it's where, let's say, node is null. Yeah, so I'll leave that format. So now for serialize, so let me just implement a standard BFS. First, let me think. I would want to, so in the base case, so if the root is, I guess we'll handle the regular case. If the root, not root, if it's empty, then in that case I just want to return whatever the result is. And regular case, add some q, and I don't remember the exact way to declare some of these, but I'll just write what I think now, and if there's any syntax errors, I'll address it after. I think that's how you declare a q in C++, q tree node, and also it should be a pointer to the tree node. Let me forget that. So pointing to the tree node, name this, say nodes q. Right, so nodes q, first thing I want to do is to push into this, the root, that's where I'm currently at. And then for BFS, it's a while. So while the queue is not empty, so I think it's nodes q dot, there's some empty function probably. And then just say while not empty. Yeah, so with the BFS, I have the queue. I push the root, check while it's not empty. I want to pop from the front. So I'll say queue has tree nodes. So I'll take out this tree node, pointer to that. I'll say node equals to nodes q, and I don't know if it's pop front or something. I'll check this later.
It's just pop.
Front?
Well,
okay.
Yeah, pop the first element.
Yeah, you're right. So it's just front, and then yeah, so I get the front, and then a node pop from the queue. It's that pop, and then so I have that node. What do I do if it's null? Because I'm serializing. So going back to your previous question to how I would want to handle the deserialization. If it's null, for example, let's say I'm going to use at. So that's the first thing that I'm going to want to check. I'm going to check that if node, if not node, if it's null. In the case of where it's null, I want to represent that as an at. So I'll say result plus equals, and I'll just say at. Yeah, so plus that equals to at. And if it's not null, then I want to do if it's not null. Let me come back to this too. So go back to this. So just regular BFS. If it is node, so establish that it's not null, then I want to push the left and then push the right because it's just a binary search tree. So nodes q dot push. I'll say do the node as a pointer, so the forward pointer left. Copy this and do the same thing for right. So I'll take the q, I do left, I do right, and then I just return the result. We're going back to line 44 to do. So if it's null, if it's not null, how do I handle this? It's not, and I want to, let me see, tree node is a val. Oh yeah, so this is a value property inside the tree node. So that's what I want to serialize. So I want to add that in there. So result plus equals to, say node val. And the value is an integer, but I'm serializing this as a string. So I'm going to convert that to a string. In C++, I know in Java it's .toString. In C++, I think it's toString.
ToString, yeah.
Yeah. So toString of that whole thing. So the at in the case of that, and then toString of the node. So that's standard BFS. Let me go over this again. So if it's not the root, just return the result here at the end. Then the queue, initialize the queue, push the root into the queue. While the queue is not empty, get the node at the front. Then update. I might have to test these. I'll come back to this. So I think this is how I'm going to do it. Just string the node the value, and then the last part is pretty standard. Push the left, push the right, and then go up and explore each level. How does that look? Well, I guess I want some. Right now, we just keep pushing a bunch of strings together, and I said at the top I want to have some delineation between them, so I just use a comma here. So I probably want to add some comma at the end because that's going to help for the deserialization. So similarly here, I want to put that. Let me see. Not node. Okay, that looks fair. How does that look? Some queue, I push, I pop. Okay, there might be a bug somewhere, but well, it's already highlighted in the queue, so it might not be important. Yeah. I should probably test this before I move to deserialize. Make sure this is working as intended. Oh, why is this red underline here? No template named Q. I don't think Q is inside IOStream. Where would it be?
Yep. Q is what?
Oh, pardon?
Sorry, I saw you asked the question.
It's given a syntax error for the Q, so I'm trying to remember what library I can import a Q from.
So it works.
Include. Okay, it's just regular Q. Okay, awesome. Thanks for that. I mentioned push. It should be push. I don't know why that's given an error. Candidate function not value if R value first. It's root. Root is a pointer. That should be fine.
I don't see anything in the program output. Oh, maybe I need
Let me run it to see.
Oh yeah, now I see it.
Yeah, it's saying for the nodes Q. I'm pretty sure the Q should be push because it works. Yeah, it works on line 1551. 0 pointer.
So there are some other. Oh, the comments. They are not. It's not Python. So.
The comments at the top. Sorry about that.
No worries.
Yeah. It's still giving that weird error. Much number function for push. That's strange.
Oh, reset because it probably still shows the old value.
Yeah.
And then okay, and so there's something new.
Yeah, it's giving some. That's strange.
That's my bad. 88.
Yeah. The curly burst goes up to that. Oh yeah, there should be one more thing here. Yeah, that matches the class. But
all right, the type mismatch is a const thing, so I define this as a const type.
Oh, okay. Oh yeah, that fixes it. Let me get rid of that. Okay, yeah, that fixed it. So let me get rid of the Deserialize as well, before I forget. Or no, that's just the data. If you're not allowed here, there's where's this? Oh, this one needs another close. There we go. So that fixes that issue. Let me put this. All right, awesome. So now let me indent these. There we go. Yeah. And then what's it given now? All right, so left dot right.
Oh, that's mine.
Oh yeah, just forward pointer.
I'll leave it to you.
Yeah, let me. What's this one saying? Right, left, useful, undeclared, infer. Oh yeah, this should be a T. Yeah, there we go. And then root that value. Okay, it's. Let me reset. Okay, so I just need to std out. Let me see. Tab left, 10, right, 20, right, 40, 40, 30. And then.
Tree. I think you need to call the serialize function.
Yeah, I'll just call it up here.
Just
If I say serialize it, let me say root. Yeah, should be a pointer to root node. Where's root defined? Okay, it's defined right there. What am I doing? There we go. That's the memory address. And then from here, the serialize will return the string. So I can just do a cd. This. So cd out. Let me run that. So warning. Oh yeah, 30, comma. Let's see, am I missing something? Serialize the roots. I takes that result. There's not return result. Then the queue, nodes queue, then push while queue is not empty. Tree node up front, pop. And then I check if that there, and the comma. So it has a 30 in the comma. Then it should push to the left and the right. Let me see what the root is. The root is 30, and then we say root left is equal to this left, and that left is 10. Then left right is equal to 20, and then right is just equal to 50, and right left is equal to 40. Okay, let me see what the issue could be.
So there's a warning on line D8. Let's fix that.
Instead of member function, serialized tree node, one control reaches end of. Oh, is it not terminated? Control reaches end of non-void function. While loop. Oh, because I have this inside the another return inside the while function. Yeah, that's the issue. Why do I have that there? Okay, that was the issue. I misplaced the return statement. Okay, there we go. Awesome. So sorry about that. Now I can jump to deserialize. And for this part, let me see. Let me go back to the comments at the top. So if I serialize it, I'll use that as the delimiter. And so I'm going to want to run BFS again and just pop from the front. And if anything is equal to @ then I know that's a null. So let me then set all at to null node value, or in this case, I guess null pointer. Null pointer node value. Otherwise, I would set it to the val. Let me think. If I do this, do that, push this, push that. Yeah, just pretty much turn in another BFS to iterate through. Okay, yeah. I think for the most part, let me try and type this out. So for deserialize, so the data, can the data be empty?
Yeah, then it's a then return non pointer in that case.
Yeah, so let me try that first case. So if data.size is equal to 0, is there an empty? Let me see.
There's also empty function.
Data empty, just return null pointer. Okay, so I'll just let me just use what's already here. Return null pointer. All right, so if it's empty, return null pointer. That's fine. Then I know I want to get some. I want to deserialize the root. So tree node. Let's say root node. So let me see what this one is expected. Oh, I'm just because I'm still typing. Equals to just a new tree node. And tree node takes its inputs. Okay. I just pass in one of these. Let's take some string data. It's data for now. I'll come back to this. So I'll come back to this part to do fix for initializing tree node with roots. Right, so assume I have some root node, and then similar to before, let me just copy some of the BFS, and I'll just modify it as need be. So I'm going to have some nodes queue. I'm going to want to push to that as before. Yeah, nodes queue, push to roots. Should be root node, that's fine. Some of the wild nodes, queue is not empty, part's good. I want to get front, that's normal. Pop, that's normal. What else is if? Yeah, so this is where I used to serialize. So now I'm going to want to deserialize right here. So the first thing I said is I have the @. So if I say if I need to parse through this data object, so I'm going to need some string. Say character. And yeah, this is what I'm going to have to pass to the tree node. And I'll have to keep Python to do parse into string. I'll come back to that. But this string is character. So if character is equal to the @ I mentioned. So if that's equal to @ then set the node value, the node left to null. Yeah, because that's going to be the next value. So if here, then here, then here. So the next one should be null. So it's node left is equal to a null pointer. And then if it's not equal to that, else, and let me, what was this if statement? Let me get rid of this before. This was from the previous function. It's not equal to that. I can initialize the actual tree node with the value node. Yeah, the node left is null pointer. Otherwise, I can set this. What do I do? Yeah, so before I said node left equal null pointer, so this time node left should just be a new tree node. New tree node that just takes in that character. And I come back to the syntax errors. And so after I create that, I want to push that into my queue again. I want to forget about that. Use that. Push. Oh, I'll have to it's on a separate line, so I can just easily push it into my queue. Node left, tree node character, and then here I'm gonna set that node left to left node, and then push that to, okay, yeah, so keep pushing the left and right to the node's queue. So this covers the left side. So similar, I need to do the same thing for deserializing on the right side. So let me think. Yeah, so that's the left. And then similarly, things should stay the same between the right and the left. So let me just quickly update these. Node left, node right, right. Let me see. So node right. I set that to null pointer if it's that. Otherwise, create the new tree node, set the right to that tree node, push to the queue. I'm forgetting anything.
I'm curious. Why? How do you know if it's a left, if this character is for the left node or for the right node?
Yeah, I want to distinguish between the two. So in that case, okay, so I know if I'm given a node, because you said it's a binary search tree, then you know the next value would have to be the left, and then the next value from there would have to be the right, because generally when you give, how we serialize it is we give the node, the left, then the right. So
just to clarify,
yeah,
it's a binary search tree, but when you're encoding the binary tree into a string, this property kind of doesn't apply anymore. And given this a string, 10 50 at, this basically means that all those properties have been erased based on how you iterate the tree.
Yeah.
So you might not be able to just by telling the tree structure from the value of the nodes in the deserialize function.
Yeah. Yeah, because the at would represent the null value.
Yeah. Pretty much all the topology information you need is encoded in string, and you might get it from there.
Yeah. So yeah, because I have the comma to separate each of the values. So that's the part I have to address that part, because I have on line 50, I put the node and the comma, somewhere with at and the comma, so I want to separate based on that. So how do I get the, I'm going to go back to the top because I know I skipped some things. So going back to line 69, so when I'm actually parsing the data into the string, so I need to, it should be a stream for the data. So is it stream? Is it S stream for string?
String.
Yeah, that's what it was. So string for string, and then I'll just name it stream. That would just take in data. Okay, so I create that stream object, and then if I create a stream object, and I have my character, so now I can go through it line by line. So get line. Thank God for the autocomplete. So get line, and parameters should be 3 of them. So I have the stream, then the character, and then the delimiter. Yeah, that should just be a comma. So I create a stream and pass in the data, have each character. Okay, yeah, so that should get me line by line each of the values that were serialized. So then, let me see. And for the tree node, so going back to the tree node, it's given the syntax error because I'm passing in a character, but I actually want to pass in the integer for the value. So I want to convert that string to integer, which should just be a COI, string to int. So I mentioned tree node. I guess I can create some constructor for the tree later. Yeah, do you care if I create a constructor for the tree or just set the value directly? Yeah.
That's a good idea.
Okay, so I'll get back to that after. So I have the stream, whatever, and then I have the tree node, and I convert that string to integer for that value. Let me say initialize root node with value. Then create my queue for BFS. While the queue is not empty, get the front, the string to int for all of these characters. And similarly here. So going back to your previous question, how do you know which one it is? That would go back to getting the individual value with getLine. So at each point after I pop, I want to get the line. So move to the next character in the stream. Get the next. Yeah, that should then move me over to the next character. And then similarly, when I go on the right, I'm going to do the same thing. Move over to the next one. So that should address the point you mentioned before.
Yep.
About how to ensure which it is. I'll get back to these syntax errors. So for the stream, implicit instantiation of undefined template. Oh, I guess it's a template an issue. For stream on line 70, it says implicit instantiation of undefined templates.
String?
Yeah, for the string stream.
Does that work? Sorry, I can't see that.
Oh, I can't see the errors. Yeah, it's saying.
I can see if you compile, but I won't see if you use my mouse screen.
Yeah, that's what it's saying.
There might be some bracket issue for the Deserialize function.
Let me check again. So this goes to here. Let's see where this closes off. That closes there. Okay, I have this semicolon at the end. It should be there. Similarly that. Where is class codec? Okay, so I need one for class codec. See if that matches. Yeah, matches class codec, but then this gives them. Oh no. This matches main. This one matches main. This one matches Deserialize. Yeah. Okay, so class codec is what's missing.
And also probably miss the return value.
Yeah, that's right. I have to return from the Deserialize. So let me return the. Let me see. Yeah, the root node. Right. This is the while loop. Okay, I think it should be right here. Let's return root node. All right, so address is that. Let me clear this, or reset this, and then run again. Okay, so in static memory, incomplete type. Yeah, so it's in the string stream is incomplete. The data, let me see if it's constant again. No, that's not it.
That's probably missing the headers. I mean,
all these headers.
That's true.
Yeah, that fixes that. And then the tree node, measuring for tree node kind of constructor, no welcome into. Oh yeah, so for this one, I just need a constructor. Yeah. All right, yeah, that fixes that issue. All right, let me clear reset this. Let me just make sure all the. Okay, some new ones popped up. What is the same for left? No matching constructor. I'll refactor the test cases. I'll just pass in. Goes to the tree node. We do that. And similarly here, new tree node.
So I can just declare it like this.
Oh, okay, that's even faster.
Okay.
How would you know the null values? Interesting. Okay, let me think. If I try to, let me see if I can break this up. So this would be, essentially this would just be a 30 here. Let me make sure I'm looking at this the right way. So we have a 20 here. This.
That's actually not correct.
Oh yeah, because.
Yeah, turning shouldn't be there.
Yeah.
And just thinking along this line, that's how we know the tree topology.
So you'd have to.
Turning shouldn't be there.
Yeah, it'd have to be the heuristics, because you know the left node is always less than the root node, and the right node is always greater than the root. And
yeah,
then,
that's right.
Yeah. And I know similar for each subtree, the right should always be greater than the root, and the left should always be less than the root. So you essentially have to keep track of the values in each subtree and sort of bubble it up. So you sort of start from the bottom and make sure that everything on the right and left checks out as you go up to the roots. Is that what you could do?
Close. Let's say we know for facts 30 is the top, is the root.
Okay.
So we from top anyway. Now let's say we know, like say we build the 30 as a root.
Yeah.
Now we figure out what's left and what's right in the remaining string. Like in this part, which ones are left and which ones are right. Then how would you tell that? How would you answer that question?
Yeah, I think I get what you're saying now, because I feel like I've thought about this before, because you're essentially trying to figure out the right and left subtrees based on the input string given. Let me think. I guess you would. Is it a pre-order traversal that you would do for the tree?
It's already done. Like
yeah.
It's already we already have a
string traversed.
Yes, yeah.
So that's a tree question. So you're given 30, 10, 20, 50, 40. Okay. And you said in this case, assume that 30 is the root.
Yes. Or maybe we can say that in the serialization process, we always put root node at the top. It's always what's that called? In order, pre-order. Yeah, in order traversal.
Yeah. I don't want to use a stack here. Let me think. If I do this, and I do that, this is a tricky one. So I'm essentially just taking the string of the values. They don't tell me which one is null. I'm going to construct a binary tree from essentially. So this is essentially a string or array of numbers, essentially.
Yeah.
And
think this problem kind of recursively.
Yeah.
So always like we have a root and we have its left and right subtree.
Yeah.
Then given a subtree, it's always we take the root and figure out what's its child subtree. So look at this string, for example.
Yeah.
Now we take 30 out of the picture. We know 30 is root.
Yeah.
So the 10, 20, 50, 40 are 30 subtrees. Now we need to answer the question, which of them belongs to left tree subtree, which belongs to the right subtree. And as a matter of if we know the structure, we know that the subtree is divided this way. 10, 20 is left, 50, 40 is right. And how?
That's right. Yeah, because if you do that traversal, then you'd end up with, because you definitely want to use recursion for this. And you'd essentially, I feel like you would run, would you run, no, you do a pre-order traversal and you just sort the values. You'd have to sort the values because you know the left should be smaller and the right should be greater. So essentially you're doing recursion while sorting the values as you go through.
That's close. But I need to remind you that binary search tree is sort of already sorted.
Yeah.
So actually, that's an important property.
Yeah.
So in a way, sorry, I think I need to leave some time for questions. So let me just show. So let's say we scan through this 10, 20, and we encounter 50. 50 is the first number that's greater than 30.
Yeah.
Right? But we know 10, 20 must belong to the left.
Yeah.
They are all smaller than 30.
And similarly, because 50 is greater than 40, you know the 40 has to be to the left of 50.
Yeah, and 40 as well. I mean, we could stop at 50 because it already provides a split between left and right.
So essentially, you need to find a split between the midpoint at each subtree, because the midpoint value would be the roots, and everything smaller would end up in the left subtree, and everything larger would be in the right subtree. So at each point of the recursion, you essentially find the midpoint.
Yeah, exactly.
Okay.
So yeah, that's the interesting part.
That's a tricky one.
That's all my.
20. Let me reset. Let me run that again. Okay, so serialize looks good. So now let me run the deserialize. Copy this. And the input was just, right, so the input should be some string. Okay, so let me, I guess I can do two test cases, just reuse what's already there and then create a new string that I can test with. So string 1 equals to serialize codec. And then let me do this. And then let me do a separate test string 2.
Or you can reuse the same string. Just pass the string.
Just give it a new one. And then let me just call it, let me see. So we'll do 10. Let me start with it. Yeah, 10, say at, say, I have to make sure I keep the constraint. So 10, there, 20 is greater than that. Then you have left for this, let me say 12, and then let me say 25. And then
this one, like the one generated.
Which one?
So I mean, like string 2 equals string 1.
Yeah. Oh yeah, I meant to say string 1 for that. Okay, yeah, that's true. And so let me run that.
It'll print a pointer. You might need a function too. Well, there are 2 ways to do it. But I leave it to you. Think about it, how you represent the tree.
Okay, so how do I want to handle this? Is it OStream? Let me think. Yeah, I haven't implemented, because I know in Python I just do it's got a repr in the class. In Java I just override the to string. I haven't done this in C++ in a while.
There's no easy way.
Yeah.
So either to iterate the tree and print every node.
Individual node, yeah. So I'd essentially just be running BFS again. Yeah. So I guess I wouldn't do this in production, but just for the sake of this, since I'm already deserializing inside the deserializing function, I can just print inside here. So wherever I set the value, so inside here, I'll say cd cout, and for here I'll just say, what should be it? Yeah, it should just be.
Sure that. Actually, we could pass the result from deserialize function back into serialize function.
Yeah, I guess that's one way to do it too. So let me consider this, and call that, and this. Yeah. Okay. Yeah. Nice. That's a lot easier.
Yeah. Ideally, we would want like print the whole tree. Yeah. Because sometimes there are a pair of bugs that it cancels out there. But it's a different topic. Sure. Okay. Yeah, I don't think we have enough time for this, but let me just throw something for potential. Okay. So we have a bit more characters. That's perfect. That makes it easy to implement the deserialize function. Yeah. Now let's say we remove a few, kind of like remove all the delimiters and just have a string in this form. Yeah. What do you think about the way to deserialize this string?
Okay, so imagine, I know there's no easy way to do this in C++, but you could split on the empty space. But yeah, you split on the empty space.
Then how do you tell which nodes belongs to the left tree and which nodes belong to the right tree?
Yeah, that's a good question. So you're saying this, instead of having, there's no at or any
No
character to
at.
use. Okay. And this is assuming there's no null values. You're just trying to figure out the left and the right.
Interesting.
Yeah, for sure. I guess.
So go ahead.
Oh, go ahead.
Yeah. So I work in autonomy framework. Framework is like a glue between different components. So we have control, we have perception, we have motion planning, and the framework provides kind of like an infrastructure or IPC mechanism for them to talk with each other. And also framework transparently logs all the data run on the vehicle so that we can replace them offline in the off vehicle, on the cloud, or on a local laptop for simulation, for reproducing a bug, for example.
Okay.
But framework doesn't handle the low-level logging details, like how files stored, how APIs invoked. It's like middleware between clients and the low-level services, let's say. An analogy would maybe something like Android runtime. Okay. So at the top, there are user public APIs and the users like apps. They call those API do something. And the low level below middleware, it's like say C libraries, socket, Linux kernel, and logging API, profiling API, those type of things. So it's middleware in some way.
Nice. I guess I'm curious to know, before, were you already working in the AV space?
No. My first kind of like is my entry point to AV space.
Nice.
My background is more like embedded. I work on GPU drivers and then Android and Android kernel and some system software. And then I kind of bored with the system software part. I become interested in the AV space. So I entered space like about 3 years ago and start from the framework basically. So I feel like there's a gap between system software and autonomy. So I'm not really, or this team is not really into the autonomy world, meaning the control theory, the machine learning, the modeling stuff. It's still like system software, but for the autonomy application.
Okay.
Which is why I could still reuse some of my old skills.
All right, awesome. Yeah, that mostly covers what I wanted to ask.
Okay, perfect. Yeah, so okay, if you have no other questions, then I guess we can call it a day.
All right. And yeah, thanks a lot for interviewing me.
Yeah, sure. Nice talking to you.
All right. Take care. Bye.
Yep.